Hello and welcome to SudoKanard. We're here to solve this puzzle by James Sinclair. It's called Crawl Space, and this is part of his weekly letter called Artisanal Sudoku. This is the free part of his weekly subscription, and I will link all of this in my description. So excuse me, I was already focusing on the puzzle. So this is a Kira Sudoku, which means that each of those cages contain only different digits, and the sum of those digits is in the corner. And then we have black dots, which mean that one of the digits is double the other, and black dots, which means that both digits are consecutive and they are here for disambiguation, and the lack of a dot has no meaning. We can't say those digits could very well be consecutive or in a ratio of 1 to 2. So this is supposed to be a difficult puzzle, so we'll see. I haven't solved it beforehand, so I will start with what I know about Kira Sudoku, namely that 29 cage with 4 digits is 5789. So this happens here as well. And this forms quadruples here. And I'm seeing this 6 doesn't use the 5, so it's a 2-4 pair here. And for the rest of the box, we are left with 1, 3, and 6. So this is something. Here, this 9 is not 5 plus 4, it's not 7 plus 2, it's not 8 plus 1, so it has to be 3 plus 6. And the rest of the box is 1, 2, 4. Right. Where should I look next? This 11 cage has to be 1, 2, 3, 5. That's the only option. And on this row, I'm seeing something interesting. What I'm seeing is that 1 on this row has to be here. And I know that those 13 cages must contain a 1. That's because 2, 3, 4, 5 has a sum of 14. So 13 with 4 digits will require a 1. So there has to be a 1 in here. And that removes 1 from those cells. I have to have a 1 here, which removes 1 from those 3 cells. And 12 must also have a 1. So that is a 1. This is our first digit. And then there will have to be a 1 somewhere here. Now where? So that's some kind of beginning. So this now is none of those digits, so it has to be from 3 and 6. And this is kind of interesting. And by this I mean that this digit, if it belongs to this cage, must appear here. But it could very well not belong to this cage. It could be 1, 2, 4, and 5. This is kind of interesting as well, because now those digits are not 3 and 6, so they must be from 1, 2, 4, 8. And this is 3 of those 4 digits here. And I'm seeing that this is not 1. Those are from 2, 3, 4, 6. I will pencil mark them. I usually don't pencil mark 4 values in a cell, but I've started to do this with the cages, the Kira cages, so that might be relevant. This row has something interesting in store, I think, which is that those 5 cells must include those 4 digits. And I can't put 2 of them in here. I can only put 1 of them in here. Because 5 plus 7 is already 12. I will have a total much higher than 13. So only one of those digits can appear here. And it can't be 8 or 9. Because 8 plus 1, 2, 3 is 14, and 9 makes an even higher total. So the digit in here will have to be 5 or 7, and the fourth 5, 7, 8, 9 on this row is here. So we have a digit from 5 and 7 here, and actually the same is happening here. This is completely symmetrical. So the other 2 digits from 5, 7, 8, 9 must be in here. One of them must be in here, and one of them must be here. And since this is a 13 cage, this will also have to be from 5 and 7, which means that this is actually an 8, 9 pair. We have a remote 5, 7 pair in here. And then whichever has the 7 will come with 1, 2, 3. And the 5 will come with 1, 3, 4. That is correct. If I put the 5 in here, the other 3 digits must sum to 8 without using the 5, so there must be 1, 3, 4. So we have a 5 with 3 or 4, a 7 with 2 or 3. So how am I using this? Both of them must use a 3. Perhaps I'm supposed to look elsewhere before committing to this, but there is something in here. I think I will pencil mark it that way with 5s and 7s in those cells, and those use here and there. They use digits from 1, 2, 3, 4. From what I said, 7 is with 1, 2, 3, 5 is with 1, 3, 4. So those must be from 1, 2, 3, 4. And this is useful on this row because we have a 1, 2, 3, 4, a 1, 2, 3, 4, 6 quintuple. So that, and by this I mean that those 5 cells can only have digits from those 5 digits, so they must exactly match. We must use exactly those 5 digits in those 5 cells. And so now with this, we know that this is 8 and this is 4. This is not 4, so there has to be a 4 in there. Then, so in this quintuple, first I will note that the remaining 3 cells here must contain 5, 7, and 9. But 7 and 9 are too high for a 12 gauge, so this is what's happening. This is actually a 5. And 9 here wouldn't work because it would require to repeat the 8. So that's the 7. And the consecutive cell here contains 6. That's a 9. And now this 5. So 5 and 1, the remaining 2 digits are 2 and 4. And an interesting point is that all of those cells see both of those cells. They see this one by the row, they see this one by the box, and those are really a 2-4 pair, so that none of those can be a 2 or a 4. They are a 1-3 pair. So that this is 6, this is now 2 or 4, and this is 3, and this is 6. And this is definitely some progress. So here, 5 will come with a 4, 7 will come with a 2. This 4 actually disambiguates the 2-4 pair, so I did some fancy logic. That was a bit too much, probably. On this column, 2 doesn't go in here because it would require to be accompanied with 1 or 3, and they are both down there. So 2 is high up. And those digits are the same as those. They are from 5, 7, 8, 9. And 5 can't go in there, so they are from 7, 8, 9. And 8 is in there. So we know now that on this column 5 is around here, so this doesn't have a 5. And now in this column 5 is down here, so this doesn't have a 5. And now where do we look? This column, this row perhaps. Oh, this. So this is not 1, 2, it's not 2, 4, it's not 3, 6, it can only be 4, 8. So 8 is not down there. Here, this 6 goes there. And this is a 7, 9 pair, so we can remove, or we can have the 8 and the 5. And this row still needs a 3. Down there, this is a 1, 2, 5 triple. Where is the next place to look? There are probably quite a number of them. Well, on this row we need a 6, and the only place for 6 on this row is here. So that's a 3. And I'm thinking it's time I addressed this 28 cage. 28 has 2 options. One of them is 4, 7, 8, 9. The other one is 5, 6, 8, 9. And at this point, what I can say is that 8 is in here and 9 is in there because of those digits. So none of those here is an 8. This is a 5, 7 pair. So this is now an 8, 9 pair. And I'm looking the other way. I'm not seeing any more eliminations. All right. Perhaps I should have a look at this. This is not 1 and 2, obviously. It's not 2 and 4. It could still be 4, 8, or 3, 6. That doesn't help me much, I think. I'm afraid that doesn't help me much. So perhaps I should really focus on this. This column still needs, well, the 9 up there, and the remaining cells are 1, 2, 5, and 7. So 5 or 7 has to be here. This can still be from 1, 2, 5, and 7. Oh, I've been missing this. There's a 1 in here, so that can't be a 1, so the 1 in this cage is here. This is kind of interesting, but I can still have this digit being here. Oh, this is interesting because all of those 3 cells see those 2 cells. I had made the logic in here. I had forgotten to use the same logic in the symmetrical spots. So all 3 digits here are in view of those cells, so none of them can be a 2 or a 4. Or a 3, sorry. So now we have 5, we need another 8, which can only be 5 and 3, because 7 and 1 would repeat the 1. So this is 5 and 3, and here this is 7 and 2. So now it should disambiguate a lot. It does indeed. 2 and 7 here, place the 5, the 7. That's not 7. That's a 4, that's a 2, that's 1. That's not 1. That's not 1 either. This is 1. About this here we have 1, 4, 6. This is not 6. And I'm seeing here the 4s. And by this I mean that those two columns already have 2 instances of 4 and they can't have any more 4. So that's the 4. Likewise, those columns already have 2 instances of digit 1, so this can't be a 1. That's a 3. Now this is 5, this is 3. And is that all for the time being? Really? Oh no, this now. We know more. It doesn't use 1, 2, or 4, so it can only be 3 and 6 in this order. This 6 now faces this 1, 6 pair, the 4, 1 pair, the 4 disambiguates the 8, 4 pair at the bottom. And as some great Sudoku host would say, we're cooking with gas. This 3 is not here, it's there. 2, 5 here, that's a 7, that's a 2. That's a 9, that's a 7, that's 8, that's 9. Oops, sorry about that. That's 8, that's 9, that's 8. Here I need 7, 8, 9, this is 9. This is from 7, 8. Now this 9 is not here. We have a 7, 8 here, pair, and a 9 there. So it places the 8 here and the 9 both on top. This column still needs 2, 4, 6, only 6. No, 4 could, no. 4 here would require a 7 there, and 7 is not allowed. So this is 5 and 6. This 5 puts the 2 and the 5 down there. This is 7. This here is not 7. 2 is not here because of that 2, so that's the 2, 4, 2, and 4. This is 7, 8, 7, and 8 to preserve the consecutiveness. If I guess this has to be a word. And now the finish should be pretty straightforward. 1, 5 here, 4 and 3, 9 and 6. Yes, this is it. So very nice, very nice Kira Sudoku by James Sinclair. This is called crawl space. I guess you would have to crawl to move into this space. This is what I understand from the title. So I think it's a good idea to subscribe to James Sinclair weekly newsletter, and you can subscribe to the free version or to the one where you buy some additional puzzles, which I can obviously not disclose on such a video. Thanks for watching it, and see you soon on SudoKanard.